Hello, my friends. This is Mr. Kozee, and I am welcoming you to Lesson 2, where we will talk about the different types of data and the different types of graphs that you can make with those different types of data. Just a quick note, because I know that for some of you, this is your first time hearing my voice giving you a lesson. You may be a student of Mr. Grimm or Mrs. Rawson. By now, word has probably gotten around that I stutter. But if you didn't know that, now you do. I stutter, so that'll come up in this video. You'll hear that, and the video's fine. It isn't buffering. It's me. Okay, so let's start from the beginning and continue on to the end, and then I think we'll stop at the end. So here we go. Before we can collect data, we've got to have a sense of the different kinds of data one can collect, because the type of data determines what you can do with it. Okay, and it depends on how you collected the data and what that data signifies, and we'll see examples. But for example, you really can't take if you take a survey of religious beliefs, like, you really can't find an average of those responses. That doesn't make any sense. You can look at the different proportions of people that responded a certain way, but the kind of data that a question about religious belief generates isn't the kind of data that you can take an average of. So there are two main types of data: quantitative and qualitative. You've also heard these called numerical and categorical. Numerical data, as one would expect, consists of numbers, and those numbers represent some kind of a quantity, either a count of something or a measurement of something. To contrast, qualitative or categorical data consists of labels. It consists of attributes that people have. It consists of any non-numerical information about a person or a thing. And even when you have numbers, the numbers have no numerical meaning. And for example, like, many of you play a sport, and you've been assigned a number as part of that sport. That number doesn't have any numerical significance. Just because you have a number 23, it doesn't mean that you're better than someone with number 25, or worse than someone with number 10. It's just a label for you. Okay? When we talk about mean, median, and mode, it really makes more sense with quantitative data. If we have numbers, we can do number things with those numbers. With qualitative categorical data, really the best thing we can do is compare proportions. So let's look at some examples. Here's a list of different things. Let's just run through them, and let's figure out if they're numerical, which is quantitative, or categorical, which is qualitative. Okay? So think about the populations of the top 5 cities in Ohio, what that data would look like, and what it would signify. Do you think it's quantitative or qualitative, numerical or categorical? It is definitely a quantity. It is a number. So it is quantitative or numerical data. The names of the 5 largest cities, the names themselves, that would be qualitative categorical data, because those are labels. The most popular flavors of ice cream served at Menchie's. I'm sorry, frozen yogurt. That would be qualitative categorical data. Now, we could talk about their rank, but even then, the data itself is qualitative categorical. You can't. And just a quick kind of rule of thumb, like what would be the average of red velvet and chocolate chip? Like there's just you can't do that numerically with qualitative data. The number of mocha lattes served by a particular Starbucks each hour. That is a quantity. That is a number. The volume of pumpkin spice lattes served at a particular Starbucks between September and December. That is also a quantity. That is numerical data or quantitative data. The teams in the NFL. That is qualitative data. Number of touchdowns scored by each of those teams. That is quantitative data. That is numerical data. Okay? Anything that's a label or a quality or an attribute that something has, that's all qualitative categorical data. I think that you guys have a pretty good sense of quantitative data. Here are some more examples of qualitative categorical data. If we were to ask people about their what presidential candidate they're supporting, that would be qualitative categorical. If we were to ask people what kind of car they drive, that would be categorical. If we were to ask people the age of their cars, that would be a quantity. That would be quantitative data. If we were to ask people their favorite pizza toppings, that would be qualitative data. Any question that's for an adjective or a label, okay? If it's not a number, it's definitely qualitative data. Okay, let's move on. When we talk about qualitative data, but also quantitative data, one of the big things we do, especially when we can construct graphs, is we put that data into categories. Now this is more natural to qualitative data because each data point is the category. If I were to ask a group of people what their hair color was, each response would be its own category, and then I would just I would figure out how many blondes I have, how many redheads I have, and so on. When we talk about, well, you know what? Let's move on and let's look at an example of this. I was getting carried away here. Okay, so and what we would do if we were together is I would go around the room and ask everybody to report their hair color. I can't do that here, so here's some data from a previous class. Now, you see these responses. Each response is its own category. And my job is to just go through each response, make a category for that response, and figure out how many of each I have. We'll look at these two columns here in a little bit. Okay, so let's go through these here. My first response is brown. Now, this tally row is just to kind of help me count up how many of each I have. So I have one person with brown hair, two people with brown hair, a person with blonde hair, another person with brown hair, another person with brown hair, another person with brown hair, another person with blonde hair, person with black hair, person with brown hair, person with blonde hair, person with blonde hair, person with brown hair, person with brown hair, person with red hair. And you're kind of getting the idea here, so I'm just going to pause and finish this. Okay, I've gone through the list. Oops, let's go back here. The frequency is just the sum of all these tallies. So frequency is which is this script letter F. That's just a fancy word for count. So there are 14 people with brown hair, 7 people with blonde, 2 with black, and 2 with red. Okay, we'll talk about these other 2 in a second. Let's move on. So as I said, frequency is a fancy word for count. Now, something that we commonly do is we show the sum of the frequencies, and that tells us how much data we have total, how many people took our survey. So if I just go back and add up my frequencies, I have the sum, which is this Greek letter sigma. It looks like messed up E, but it means sum in math, the sum of the frequencies, and that tells me how much data I have total. I have 14 plus 7 is 21, 23, 25 people total took my survey. So this sigma F tells me how much, how many data points I have. Okay, let's move on. What I can do then, once I know how many data points I have, is to find the relative frequency, which is basically the percentage or proportion of my data that falls within each category. And I do that just by dividing each frequency with the sum of all of the frequencies. So when we find relative frequency, it's really not that different from what you do when you get a quiz grade, like 41 out of 45, and you're trying to figure out what percentage you got. You divide your number of points with your total. So that's what we're going to do here. Okay, let me get my calculator out. There it is, and we're just going to set an option here so that it stays on top. And then I'm just gonna go and divide each of these quantities by 25 by my total. So 14 divided by 25 is 0.56. I'm going to write down 0.56. 7 divided by 25 is going to be half of that, but let's actually just do it out. 7 divided by 25 is 0.28. So what this relative frequency is telling me is that more than half of my data responded brown. A little more than a quarter responded blonde, and 8% each was black and red. Looking at the percentages can be helpful if I'm comparing two sets of responses, like say two different classes, and the class sizes weren't the same. Just looking at the counts may not be as instructive, but looking at the percentages, the relative frequencies would be very helpful. Okay, let's move on. Now, what we've just created is what we call a frequency distribution. This is actually called a frequency distribution. It tells us my categories, and it tells us the distribution of my data between those categories, either as a literal count or as a percentage, a relative frequency. This is a frequency distribution, and it's a common way that data, especially categorical data, is organized and presented. So to graph this categorical data, we really have two main options. a pie chart. Pie charts can also work on numerical data, but it's primarily categorical. And then a Pareto chart, which is a fancy word for a bar chart. Now, if we have numerical data, we have many other kinds of plots that are different that we'll look at. But because we're looking at categorical right now, let's look at a Pareto chart. And this is just a fancy name for a bar chart. Each of your bars represents a category. The height represents a frequency. It's traditional that you organize your categories from most frequency to least frequency, unless there's a good reason not to. For example, with our hair colors, it really only makes sense to put my largest category first, my next largest second, and so on. If we look at, like, if we were to survey the month in which you were born, okay, months kind of have a natural order to them, so it wouldn't make sense to put June first, because even if it has the most respondents, because June is the 6th month. Okay, so let's make a Pareto chart on hair color in Google Sheets. So I'm going to break out of this presentation for a second. I'm going to go over here to my web browser. The link to this is in the comments to this video. So hit pause, bring this up, and make a copy. Okay, so the good news is that when you're making charts in Google Sheets, and this also is true for Excel, it's pretty smart as far as figuring out what you want to do. So I'm just going to highlight, and if you notice, I organize this so that my largest category is first. I'm just going to highlight this whole thing. I'm going to go to Insert Chart, and it's pretty smart about figuring out what I want to do. Now, it started out producing a pie chart, which is we're going to talk about in a second. But let's switch over to a bar chart, and there we go. We have brown hair, blonde hair, red hair, and black hair. Frequency on the left side. I could maybe give this self-reported hair color from 25 people. Okay. Now a couple things I can do, like maybe I want to color my bars. Can I color my bars? I think if I color one, it's going to color all of them. This is kind of how this type of presentation works. Let me show you a couple things you can do with a Pareto chart in Google Sheets. So I'm going to delete this for just a second. Oops, too far. I can also let's say this was one group of people, one of my classes. So this was, let's say, period 1, first period, and then second period had a slightly different set of responses. Okay. One thing I can do is I can combine these all into one chart. I just have to make sure that I select everything and insert chart, and it figures out that I want 2 charts. Now, I do need to go to a bar chart. Now, this has a couple of different presentations. This is called a stacked chart, where it combines the 2 sets, but also separates them. You can also do side by side, that's further down, like this. So period 1 is in blue and period 2 is in red. Okay. Another thing that I can do is, let's say I have this and I just want period 2. I hold down the control key and I select this first column, and then I come over here and select this second column. Okay, so holding down control, I select 2 separate columns, and then it will just give me the graph. Let's go back to a bar chart. It'll just give me the graph of that data. Okay, so that's a Pareto chart, and it's a very common way of presenting categorical data. Okay, let's move on and talk about a pie chart very quickly. A pie chart is a presentation of relative frequency, and it demonstrates what proportion of your data falls within each category. You have you have a pie, a whole pie, and whatever percentage each category is a percentage of the pie. Now the key thing that a pie chart is created around is the wedge angle, which is the angle that the slice at the center makes. And it's equal to the relative angle times 360, and this is how a pie chart is created. So, for example, let me pull up my my calculator here, and this will be the last thing that I do in this video. I'm going to end it after this, and then we'll take a break, or you'll take a break. I'll keep on recording. So what I'm going to do is just take each relative frequency multiplied by 360. I'm going to do let's try that again. By 360, and I'm going to round that to the nearest degree. So this is get my pens here. This is 202 degrees. 0.28 times 360, and that's 101 degrees, which kind of makes sense. And then 0.08. Is let's say 29 degrees. 29 and 29. Okay, because of rounding, these don't always add up to 360, so sometimes you have to make compromises. But then when you go to construct a pie chart, you then just go around a circle and measure out each angle and draw an angle from the center. Now, I'll be honest, I'm showing you this so that you have a sense of how a pie chart is constructed. No one ever actually does this manually. They use a tool like a spreadsheet. So let's go back into our data, and I already showed you how to do a pie chart. You select it, you go Insert Chart, and that's the first thing that that Google Sheets comes up with. Now, one note: usually it doesn't matter how your slices are colored. But it is sort of weird that the blonde slice is red and the red slice is blonde and the black slice is green. So maybe what we can do is click on each slice and pick a color that's maybe a better match for so for blonde we'll pick more of a light yellow, and then for red we'll pick kind of of a darker red, and for black, we'll pick a darker color so that the slices, look a little closer to what they represent. Okay. Now, just as a side note, and we saw this, but I want to point it out. If I select multiple sets of data and go to Insert Chart, the first thing that Google Sheets does is it combines them. So this is the combined data from periods 1 and 2. If I want to separate them out, I know Excel has a chart like this. I'm not sure Google does. There's a donut chart, but I don't see an easy way of separating out these as two sets of data. Excel will create two rings, and each ring represents a set of data. But okay, anyway, let's cut this off here and take a break. And when we come back, we'll look at numerical data. Okay.